स्क्रीन सभी को विजिबल है? स्क्रीन इज विजिबल टू ऑल? जस्ट ए सेकेंड यार. ओके नाउ. Screen visible to all of you? Am I audible to all of you? Hmm? Okay. What about others? JNV Shimoga, class 12th students, JNV Raichur. What is your name, class 12? Could you please write up your name? Class 12. Could you please write up your name in the chat box? Okay. So, आप में से कुछ स्टूडेंट है जो अपना प्रॉमिस पूरा कर रहे हैं, डेली क्लास में आ रहे हैं. But some of you have broken the promise, and that's not a good thing. Okay, JNV Gadchiroli. Got it. JNV Kodinar is also here. Very good. चलिए तो let's just get started. Good afternoon to all of you. I welcome you all in this session of electrostatics, and this is our lecture number 11. Okay. In the previous session, what we have did, we have taken a continuous charge distribution and see the different cases of it. Okay. We have seen the electric field due to a line charge distribution, due to a ring, and also seen the expression, just the expression for disk. Okay. Then we have also seen a beautiful expression when we place the rod in vertical position, है? And we relate two types of field there in terms of angles, sine alpha and cos alpha. I hope who has present in the previous class should have the memory to remember it. And yeah, you are taking up the notes there. Okay. So in this class also, we are going to finalize this chapter in the today's class, if possible. Okay. So the topic of today's class is Gauss law. Although the basic that is required to acknowledge this concept, this Gauss law, I have already told you. If you have paid attention to the previous lecture, we have discussed about the electric flux. And Gauss law is nothing but the relation of electric flux with the electric field and charge enclosed. Okay? So this is nothing but the electric flux का relation with the charge enclosed. Okay? So we are going to deep down into it. After that, we will see the applications of Gauss law. Okay? So application of Gauss law is really important, and you should pay attention to this. You must pay attention to this because it is really going to help you. And the derivation that we have did for line charge, the expression that we have seen for disk, uniformly charged disk, that is very easy to calculate the electric field with the help of Gauss law. Okay? You will find that particular expression within seconds. Okay? Now, so let's just move on to the Gauss law. So the statement of Gauss law is nothing but it states that, try to take the note of it, electric flux phi through a closed surface S is 1 by epsilon naught times of charge enclosed by the surface S. ठीक है. Now let me read again. Electric flux through a closed surface S is 1 by epsilon naught times of the charge enclosed by surface S. ठीक है. जितना भी चार्ज उस पर्टिकुलर सरफेस ने इनक्लोज किया होगा, electric field, electric flux through this surface would be charge enclosed by the surface divided by epsilon. 1 by epsilon naught का क्या मतलब हुआ? 1 by epsilon naught multiplied by q enclosed. So it is q enclosed per unit epsilon naught. ठीक है. Now let's just see it, how this law behaves. ठीक है. This is the statement. अब recall the previous lectures. We have seen that electric flux is nothing but the electric field vector dot ds vector. Ds is the area vector. And we integrate it, you will get over the flux through the entire surface. ठीक है. पूरी सरफेस से जितना फ्लक्स जा रहा होगा, it is given by this E vector dot ds vector. एंड ई डॉट डीएसई कब लगाते हैं? तब लगाते हैं जब इलेक्ट्रिक फील्ड का वेरिएशन इज नॉट यूनिफॉर्म. ठीक है. और द सरफेस इज नॉट यूनिफॉर्म, सरफेस इज नॉट सिमेट्रिक. इन दैट केस वी विल अप्लाई दी दिस फॉर्मूला ए डॉट डी एस. नाउ यहाँ पे आपको एक स्पेशल टर्म दिख रही होगी, दिस सर्कल. दिस सर्कल मीन्स क्लोज्ड इंटीग्रल. क्लोज्ड इंटीग्रल, इंटीग्रल तो ये है ही, इंटीग्रेशन तो ये है ही, बट दिस क्लोज सर्कल मींस दिस इज अ क्लोज इंटीग्रल. क्लोज इंटीग्रल का मतलब क्या होता है? जिस भी बाउंड्री के ऊपर आप, जिस भी बाउंड्री को आप सम कर रहे हो, सरफेस को, जिस भी सरफेस को आप इंटीग्रेशन जिसका भी निकाल रहे हो, वी आर समिंग ओवर दिस एंटायर सरफेस ds. तो दिस सरफेस मस्ट बी क्लोज. ये सरफेस ऐसी नहीं होनी चाहिए, खुली नहीं होनी चाहिए. ठीक है. वॉइड नहीं होने चाहिए सरफेस. द सरफेस मस्ट बी क्लोज. ठीक है. when you going to do your engineering, you will get to know what does this mean of this closed integral. ठीक है. And there are three types of integral. This is the line integral, this is surface integral, and this is the volume integral. So these three types of integral you have to study them. Okay. Got it? Now, so suppose this is a surface S. This yellow color lines is the surface, and you can see this is closed surface. कहीं पे भी void नहीं है. ठीक है. There is no entry point. So this surface is the closed surface, and in this surface we have charge q1 minus q2 minus q3 q5. We have two extra charge also, but they are present outside the surface. ठीक है. So to give you the feel of Gauss law, I have taken these two charges outside. ठीक है. Why? You will get to know. So if I apply the Gauss law here, so Gauss law states that phi electric is equals to the charge enclosed by the closed surface divided by epsilon. Now you can easily tell me that sir, q1 minus q3 q5 and minus q2 are the charge which is enclosed by this surface. So this phi electric would be q1 minus q2 minus q3 plus q5 divided by epsilon. ठीक है. Over this surface, and this is pretty much understood. These charges are inside the surface. So whatever the electric field lines passing through this surface will be caused by these charges. So flux through this surface will be the resultant of electric field lines enclosed by this surface. ठीक है. Got it? So that is why we consider the only enclosed charge. ठीक है. Now next, अभी ये स्टेटमेंट क्लियर हुआ. स्टेटमेंट क्लियर हुआ. क्यू इनक्लोज्ड का क्या मतलब है? द चार्जेस which is present inside the surface, you have to take only those charges. ठीक है. Like in this case, q1 minus q2 minus q3, q5 is only considered. q4 and q minus q6 is not considered. ठीक है. Now important point. So the first point regarding this law, and I'll tell you a very important note here, that Gauss law, or I will write it here, Gauss law is important, but not useful. इस बात को बिल्कुल दिमाग में रखना कि Gauss law is very important, but it is not useful. And later you will get to know कि why it is not useful. ठीक है. So Gauss law, the very first point, Gauss law is true for any closed surface. कैसी भी सरफेस हो, लेकिन अगर वो क्लोज है तो Gauss law is valid for that, no matter that surface is which shape. ठीक है, or size. Either you will take this or you will take this one. You will take a perfect circle, you have taken a rectangle, you have taken a square, you have taken an ellipse, whatever. If these surfaces are closed, so Gauss law is valid for them. You can apply the Gauss law there, no matter what is the size and what is the shape. This is the very first point you should remember. Now, the condition is that it is applicable only for any closed surface. So surface must be closed. कहीं पे void नहीं होना चाहिए. Now, तीनों तरह की सरफेसेस के लिए फ्लक्स क्या होगा? इक्वल होगा. Here, क्योंकि चार्ज इनक्लोज कितना हुआ? What is the value of charge enclosed? Q enclosed over epsilon naught. So apply here. So Q enclosed by this surface S1 is Q1 Q3 minus Q2, and by this surface S2 is also Q1 Q3 minus Q2. So charge enclosed is same, which means the electric flux will be same. So this is verifying the very first line, that Gauss law is true for any closed surface, no matter what the shape and size. Here both the surfaces S1 and S2 have different shape, different size, but the electric flux is same. Okay. Now, the term Q enclosed on the right sides of Gauss law equation included the sum of all the charges enclosed by the surface. The charges may be located anywhere inside the surface. Means it is not important. Suppose these two surfaces I have considered, S1 and S2. Here's the charge Q1. Here's the charge Q2. If I place the charge Q2 in this surface here and Q1 here, so it does not matter what is the distribution of charge inside the surface. Okay? If the total enclosed charge is Q1 and Q2, and here is also Q1 and Q2, then the flux will be same and this Q enclosed will be same. Okay? This is the thing. Now the very important point here, for which the Gauss law is to be studied, this one. Flux ko we can also write. Flux is also written as closed integral of E vector dot ds. Closed integral वैसे नहीं होता. If you study the flux itself, then you don't need to apply this closed integral. But when you are studying with the help of Gauss law, then you have to apply the closed integral because the surface must be closed. Okay? Now, if you put this equation here, so this Q enclosed by epsilon naught will become line closed integral of E vector dot ds vector. Okay? This Q enclosed is the surface charge which is enclosed by the surface. This is the Q inside the surface, है ना? But what about this field? ये field किससे है? Is this field because of the charge enclosed or the total charge? So always remember, this electric field is due to the entire charges present, either it is inside the surface or outside the surface. दोनों चार्जेस की वजह से ही ये इलेक्ट्रिक फील्ड आती है. ठीक है? So this is really important point. Take a note of it. The electric field due to all the charges. The electric field is due to all the charges, both inside and outside. Got it? Clear है? Anyone any kind of doubt? सभी को क्लियर है? Everyone clear with this? JNV Yanam, Raichur, JNV Gadchiroli. Okay. JNV Shimoga. आज तो आपको जवाब देना ही होगा भाई. कोडिनार, पंचमहल. Everyone has to answer. ठीक है? Okay. Now, so I hope this is clear to all. And this is a very simple thing, है ना? Very simple concept. Now move on to the next slide. Here, the application part of Gauss law has started. To apply the Gauss law, now we will consider a Gaussian surface. Now, what is this Gaussian surface? And why we need it? Then, suppose there is any charge distribution through this surface. Let's say this is the surface, and here we have distributed some of the charges. Okay. Now, we are interested to find out the electric field. Okay. Okay. We can find out with the help of Gauss law. Why and how? Phi electric flux क्या होता है? Gauss law के according. It is Q enclosed divided by epsilon naught, and it is also equals to the closed integral of E vector dot ds vector. Got it? So we can remove this and take this as the new equation. Okay. In this equation, if you have noticed, there is a ds, and ds is the surface integral, surface area. ds is what? ds is the surface area, differential surface area. Differential surface area. Okay. Differential surface area is the very small area. This one, very small. Now, when you add all these surfaces area, which means integration of ds will result in S, which is total area. ये तो सभी को clear है. ठीक है? Because any surface is made up of these small surface areas. ठीक है? Now, so to apply the Gauss law, we must know what is the surface area of it. Okay. The surface over which we are applying the Gauss law, what is the surface area of that surface? Sometime you know, sometime you don't know. Suppose that the surface is like this. Can you get the value? Can you calculate the surface area of this particular shape? No, it's not possible. Okay. So for that, if you consider that this surface itself is enclosed in this circular surface, so suppose there is a charge present here, so whatever the field will be created, the field will go like this. So this particular dotted surface is nothing but the Gaussian surface. So we will choose it because we do not know the surface area of every surface. Okay? So that is why we choose this Gaussian surface to apply the Gauss law. Okay? I hope this concept is now clear to you. Now, there is some rules to apply the Gaussian surface and make the Gaussian surface. How the Gaussian surface should be look like? It will be a circular, it will be a cylinder, it will be a plane or trapezoidal. What it be shape? What is the shape of Gaussian surface? So that will be decided by some of the factors, and we will discuss them one by one. Okay? Now, so the surface that is chosen for the application of Gauss's law is called Gaussian surface. Okay? And that is why I have told you that Gauss law is important but not useful, because the surface area you do not know. You cannot apply. You can apply the Gauss law here. But what is the surface area? You don't know. So it is applicable or it is useful only for the symmetrical surfaces or the surface for you for which you know the formula of surface area. ठीक है ना? Now, so important point, कोई भी Gaussian surface आप choose कर सकते हैं. This, but उसके लिए condition क्या है? You must know the surface area. So definitely in three of them you are going to choose either this or this, because इसका भी आपको surface area पता है if this is a sphere, and इसका भी आपको surface area पता होगा if this is a cylinder. But what is this? This is nothing at particular. So surface area we do not know, so we will not consider it as a Gaussian surface. Okay? But if you are a good mathematician and you can calculate the surface area over this surface, so you can apply the Gauss law here. Okay. Now, this is the really important condition for Gaussian surface. For Gaussian surface is chosen such that the electric field either perpendicular or parallel to the area vector of Gaussian surface and magnitude of electric field is constant at every point of the Gaussian surface. Now let us understand it in a detailed manner. देखो, if the electric field is perpendicular to ds vector, then in that case what would happen? It has been said na, electric field is either perpendicular, which means the angle between electric field and area is 90 degree. So if it is 90 degree, cos 90 will become 0. So this total calculation will vanish out to be 0. So the flux will be 0 there. Okay, for theta is equals to 90. And if E is parallel to S, then in that case, this cos theta will be 0, cos 0, and cos 0 is 1. Okay. So for that surface, we can also calculate the electric. Okay. Like this. Now, अब देखो, एक क्वेश्चन की मदद से समझते हैं. A point charge Q is placed at the center of a half sphere. Find out the electric plus passing through the surface. So suppose this is the charge and it is a positive charge. ठीक है. पॉजिटिव चार्ज से फील्ड कैसी होंगी? फील्ड लाइंस रेडियली आउटवर्ड. ठीक है. अब आप लोग अपना दिमाग चलाओ थोड़ा और बताओ, can I choose this as a Gaussian surface? Let me change the color of the pen. Should I choose this as a Gaussian surface? A rectangle one? Should I choose this? Is it fulfilling the condition? No. Why? Because here the field is at 90 degree, but here the angle is not 90. Here is it 90, here is not 90. Okay? Which means the variation of electric field is not uniform over the surface. So we cannot consider this as the Gaussian surface. Okay? So what would be the next option? Next option क्या है? If I choose, this is the field lines. If I choose a uniform sphere, अभी तो ये आपको सर्कल दिख रहा होगा, बट दिस इज अ यूनिफॉर्म स्फीयर, क्योंकि फील्ड लाइंस भी हर डायरेक्शन में पास आउट हो रही होगी रेडियली। ठीक है, इफ यू सी दिस एट एवरी पॉइंट ऑफ टाइम, this is the surface area, small ds. So area vector would be perpendicular, normal to the surface, and the field is also in this direction. So angle between them is zero. At every point of time, you can check the angle between electric field and ds vector is 0 degree. ठीक है, क्योंकि इस तरह की सरफेस है, एंड दिस इज फील्ड लाइन। ये फील्ड लाइन जिस सरफेस एरिया से पास कर रही है, दैट इज वेरी स्मॉल, ds। ये सरफेस एरिया का परपेंडिकुलर क्या होगा, इसी डायरेक्शन में होगा, नॉर्मल, नॉर्मल टू द सरफेस, which means ds vector and e vector are in same direction. So for a point charge or a spherical charge distribution, we will choose Gaussian surface as a spherical surface. So here Gaussian surface, Gaussian surface is spherical one, spherical surface। ठीक है, आप क्वेश्चन को पढ़ो। ये तो डिसाइड हो गया कि विच टाइप ऑफ सरफेस वी हैव टू चूज, वी हैव टू चूज अ spherical surface। now this charge q is placed at the center of half sphere। ठीक है, center of half sphere। this is a sphere, half sphere actually, and here is the charge present। suppose this would be a full sphere, so in that case what would happen, half of the flux pass through the upper half of the flux pass through the lower half। ठीक है, so we can say that according to Gauss law, phi is equals to what? Phi is equals to Q enclosed divided by epsilon। अब मुझे आप एक बात बताएं, क्या इस हाफ स्फेयर ने कंप्लीट चार्ज को इनक्लोज किया हुआ है? कंप्लीट चार्ज इज इनक्लोज बाय दिस हाफ स्फेयर? नो, बिकॉज से जो फील्ड लाइंस जाएंगी वो इस तरह भी तो जाएंगी ना ऊपर की तरफ। सो दिस इज ओपन, this is not covered, which means only half of the flux will pass through this surface। ठीक है, which means that this is 1/2 times of q upon epsilon। क्लियर है, सभी को क्लियर है? everyone is clear with this question? any kind of doubt you having? huh? and suppose this charge is present at the center of sphere, so in that case what will be the flux? It is present at the center of the sphere, then in that case what will be the flux? Flux will be charge enclosed by epsilon naught। clear है? any kind of doubt? JNVNM and other students also, JNV Raichur, 12 science, Codinar, any kind of problem in this question? If you have any kind of doubt, you can ask me। okay? now this one, yeah, ठीक है, find the flux passing through a cube if charge q is placed, ठीक है, at the center of a cube, at the face of a cube and at a corner of a cube। ठीक है, तो यहाँ पे हमें तीन टाइप दिए हुए हैं, सेंटर पे जब हम रखेंगे, और फेस पे जब हम रखेंगे क्यूब के, और कॉर्नर पे जब हम रखेंगे, व्हाट इज द फ्लक्स पासिंग थ्रू द क्यूब? दिस इज द क्यूब दैट वी हैव, लेट्स से दिस इज द क्यूब। Okay. When we place a charged particle at the center of the cube, the very first case, charged particle is present here at the center. So whatever the field lines it will generate, it will pass through all the faces. ये क्लियर है सभी को, है ना? सभी फेसेस से पास होंगे. और for your easiness, I will do it like phi enclosed. Phi electric is nothing but the Q enclosed upon epsilon naught. So for your easiness, what we will do, we will take this cube as a Gaussian surface. Cube को ही हमने क्या consider कर लिया? Gaussian surface, because we only interested in the electric flux, not the electric field. So we can consider this Q enclosed, sorry, this surface as a Gaussian surface. Gaussian surface. ठीक है. अब Gaussian surface ने कितना चार्ज इनक्लोज किया है? Let's say this charge is Q. Who is going to tell me how much charge this cube has enclosed itself? Anyone? JNV Ramnagar, 12th Science Kodinar, JNV Yanam, Raichur. Anyone? How much charge does this cube has enclosed? कितना चार्ज इनक्लोज किया हुआ है? It is clearly visible. It is clearly visible. Not one. Q charge is enclosed. This Q charge is enclosed. ठीक है? Okay. So, and what is the Gauss law? Gauss law is saying that Q enclosed and flux through any surface is Q enclosed by epsilon naught. And what is the Q enclosed here? Q enclosed is Q. So flux through the surfaces in first case, it is Q upon epsilon naught. Clear? Clear? Now, the second case, देखो ऐसे हुए. Second case is when charge is placed at the face of the cube. Face होते हैं ये, these walls. These are the face. How many face a cube have? बताओ. जिस भी रूम में आप बैठे हो ना, आपकी क्लासरूम, वो भी एक क्या है? वो भी तो एक क्यूब ही है. अब उसकी जितने भी वॉल्स हैं, ठीक है, जितनी भी सरफेसेस हैं, उन्हें काउंट करो. देन यू विल गेट द नंबर ऑफ फेसेस. एक तो आपके सामने होगा, जिस प्रोजेक्टर में आप ये प्रोजेक्टर की जो इमेज आ रही है, जो आप देख रहे हो जहां से, एक तो वही फेस हो गया. एक उसके जस्ट पीछे जब आप बैठे हो जिसके, है ना? एक आपके ऊपर है, एक नीचे जिसे फ्लोर बोल रहे हो. चार हो गए. और दो साइड में हो गए. एक इधर हो गया, एक इधर हो गया. तो टोटल कितने फेस हुए? टोटल फेस ऑफ अ क्यूब इज 6. ठीक है. थोड़ा इमेजिनेशन करना पड़ता है, ये क्वेश्चन आते जरूर है. टोटल फेस इज 6 इन अ क्यूब. अब आप खुद सोचो, अगर ये किसी भी पर्टिकुलर फेस पे रखा हुआ है चार्ज, सो इट इज प्लेस लाइक दिस. अगर ये फेस है ना, तो चार्ज ऐसे रखा होगा, हाफ अंदर हाफ बाहर. ऐसा क्यों मैं बोल रहा हूँ? क्योंकि जो भी इलेक्ट्रिक फील्ड लाइंस पास होंगी, वो हाफ ही जाएंगी अंदर क्यूब के, और हाफ जाएंगी बाहर. ठीक है. नाउ अब देखो, इस तरह के क्वेश्चन को करने के लिए व्हाट यू शुड डू, यू विल टेक दिस चार्ज, ठीक है, एंड try to cover the complete charge and measure how many extra cube you required. ठीक है. ठीक है. Suppose this is the cube, this is the cube, and इस face पे this is the charge present. So half of the charge is outside, half of the charge is inside. So how many cube do I require to cover this? Only one, है ना? If I place another cube near to this charge, so this charge is enclosed, completely enclosed, but the number of cubes has been increased by 2. ठीक है. So in that case, this charge you will be shared by 2 cubes, and this second cube is just imaginary. It is not actually there. It is just to cover the charge. Now एक क्यूबॉइड से कितना फ्लक्स पास आउट हो रहा था, क्यू अपॉन एप्सिलॉन नॉट, पिछले केस में हमने देखा, ठीक है। और ये क्यूबॉइड किससे मिलकर बना है, दो क्यूब से। तो एक क्यूब से कितना फ्लक्स पास होगा, हाफ ऑफ द टोटल फ्लक्स, ठीक है। कंप्लीट क्यूब से कितना फ्लक्स पास होता है, क्यू अपॉन एप्सिलॉन नॉट, ठीक है। तो द फ्लक्स पास थ्रू द एवरी क्यूब विल बी 1/2 क्यू अपॉन एप्सिलॉन नॉट, क्योंकि टोटल जो इस क्यूबॉइड से पास आउट हो रहा है फ्लक्स, दैट इज क्यू बाई एप्सिलॉन नॉट। सो हाफ से कितना होगा, ओनली दिस वन, जस्ट हाफ कर दो, ठीक है। वॉट इट, क्लियर है सभी को, एवरीवन क्लियर विद दिस? आई होप दिस इज क्लियर टू यू। इफ एनी काइंड ऑफ डाउट यू हैविंग, यू कैन आस्क, ठीक है। ओके, नाउ मूव ऑन टू द नेक्स्ट वन। when charge q will be shared by 8 cubes। अब चार्ज कहां पे रखा हुआ है, सी केस में चार्ज इज प्लेस्ड एट द कॉर्नर, ठीक है। सो सपोज करो कि आपकी जो क्लासरूम है उसके कॉर्नर पे आपका जो है एक बल्ब है, ठीक है। अब उस बल्ब का जो ग्लो है वो पूरा का पूरा रूम में आ रहा हो, ठीक है। बल्ब की जगह आप एक कंसिडर करो फुटबॉल, ठीक है। सो इफ यू वांट टू प्लेस द फुटबॉल at the corner, does it touch the surface? No. So to make it touch, you have to place the football like this. That is not possible actually, but you can imagine it. So only this portion will be shared by this corner. And how many corners you have, how many corners in a cube, tell me. So corners in a cube is number of corner in a cube। देखो अपने रूम में कितने कोने हैं, देखो, the one is this, second, third, fourth, fifth and sixth one is नीचे होगा इधर, 7 और 8। so this charge will be shared by 8 क्यूब। अगर मैं 8 क्यूब एक के ऊपर रख दूं, एक के ऊपर एक रखूं यहाँ पे, तब मैं इस टोटल चार्ज को कवर कर पाऊंगा, ठीक है। देखो कैसे, फर्स्ट, सेकेंड, 3 क्यूब हो गए, फोर्थ, फिफ्थ, सिक्स्थ, 7 और 8। अब ये चार्ज क्या होगा, ये यहाँ पे है कहीं इन बिटवीन में, ठीक है। गॉट इट। तो अब ये टोटल चार्ज कवर हो रहा है, ठीक है। अब एक क्यूब से कितना जाता है, क्यू अपॉन एप्सिलॉन नॉट। तो ये एक क्यूब का कितना है, 1/8 है। तो कितना हो जाएगा चार्ज शेयर, 1/8 टाइम्स ऑफ क्यू अपॉन एप्सिलॉन। एंड नाउ आई विल टेल यू द ट्रिक ऑफ इट, हाउ टू डू इट। देखो, जब भी चार्ज, उसने कहा कि चार्ज इज प्लेस एट द फेस, ठीक है। चार्ज इज प्लेस एट द फेस, किसी भी फेस पे, तो देखो कि कितने क्यूब आपको रिक्वायर्ड है उसे कंप्लीटली कवर करने के लिए। सो वी हैव सीन इन द प्रीवियस केस कि 2 क्यूब्स इज रिक्वायर्ड। सो फ्लक्स विल बी q by epsilon naught. How many cubes required in case of face, 1/2? So this will be the flux from the individual cube. In case of corner, how many cubes you require? In case of corner, how many cubes you require? We require 8 cubes, क्योंकि number of corner are कितने, number of corners are 8, so 8 cube we required to cover that charge। so flux through each cube will be q upon epsilon, ठीक है। which means कि अगर कोई चार्ज किसी क्यूब के कॉर्नर पे प्लेस है, कॉर्नर पे कोई चार्ज प्लेस है, तो उस चार्ज का सिर्फ 1/8 ही फ्लक्स उस क्यूब से पास आउट होगा। गॉट इट? क्लियर है? क्लियर है ना? ओके। जेएनवी यनम, 12 साइंस, रामनगर, अहमदनगर, बताइए, एनी काइंड ऑफ डाउट इन दिस? ओके, ओके, नाउ मूव ऑन टू द नेक्स्ट टॉपिक, एप्लीकेशन ऑफ गॉस लॉ। तो सबसे पहले एप्लीकेशन ऑफ गॉस लॉ में वी विल डू the electric field the electric field due to a line charge. Application of Gauss law is very simple. By the meaning of application of Gauss law, we are targeting to calculate the electric field due to different charge distribution. ठीक है? Now this is a line charge. So line charge से electric field lines कैसी होंगी? देखो, line charge से electric field lines will be like this. क्योंकि line charge is a combination of multiple point charges. एक के बाद एक पॉइंट चार्ज को सटा के रख दिया तो क्या मिला? लाइन चार्ज। ठीक है? इफ यू प्लेस द पॉइंट चार्ज along with each other in a line, then you will get a line charge distribution. And point charge से फील्ड कैसे पास आउट होती है? रेडियली आउटवर्ड। ठीक है? if is a positive charge and radially inward if it is a negative charge. So इससे फील्ड लाइन कैसे पास करेगी? देखो अगेन, देखो फील्ड लाइंस कैसे पास करेंगी? ऐसे, रेडियली आउट। ठीक है ना? सो वी हैव टू फाइंड सच अ गॉसियन सरफेस कि उसके लिए ये जो फील्ड है या तो ये एरिया वेक्टर के परपेंडिकुलर हो या फिर एरिया वेक्टर के पैरेलल हो। तो ऐसी कौन सी सरफेस होगी? बताओ। देख, अगर मैं इस लाइन चार्ज को कवर कर दूं इस छोटे से सिलेंडर से, तो क्या ये सिलेंड्रिकल सरफेस, we cannot consider it to be a Gaussian surface? Because if you pay attention to it, each and every time, the electric field lines are parallel to the area vector. क्यों? देखो, इसका ये फ्रंट व्यू है। फ्रंट व्यू कैसे है? द लाइन चार्ज इज कमिंग लाइक दिस आउटवर्ड एंड दिस इज द सिलेंड्रिकल शेप। अब इससे फील्ड लाइंस कैसे पास करेंगी? ऐसे, सेम ये सब चीजें देखो, ऐसे फील्ड लाइन पास करेंगे। नाउ कोई भी कंसिडर करो, कोई भी सेक्शन आप कंसिडर करोगे, इससे जो एरिया वेक्टर होगा, द वैल्यू ऑफ एरिया वेक्टर, द डायरेक्शन ऑफ एरिया वेक्टर विल बी परपेंडिकुलर, which is also normal to the surface, and field is also normal to the surface, which means the angle between E vector and area vector is equals to 0. So what would be the possible Gaussian surface for a line charge? It will be a cylindrical surface. क्लियर है? क्लियर है सभी को? जब आप क्लास से फ्री होंगे ना और आप सेल्फ स्टडी करेंगे तब आपको पता चलेगा कि हाँ, वाकई हमें ये सिलेंड्रिकल सरफेस क्यों लिया। ठीक है? नाउ दिस वुड बी दी सिलेंड्रिकल सरफेस की जो रेडियस है सिलेंड्रिकल सरफेस की, इट्स आर, एंड लेंथ ऑफ दिस सिलेंडर इज एल। ठीक है? So we have considered a cylindrical Gaussian surface coaxial with the wire of radius r and length l. ठीक है? This is the radius of cylindrical surface and this is the length of cylindrical surface. Now we will consider a point P here. इस point P पे what is the direction of field? Field will be outward. And what is the direction of एरिया वेक्टर? एरिया वेक्टर भी क्या होगा? आउटवर्ड नॉर्मल होगा। area vector is also outward normal. But in this cylindrical arrangement, if you will see carefully, in this cylindrical arrangement, we have three surfaces. The first two are the base area, these, and the third one is this curved surface, this curved surface, this one. Okay. So we have total three surface area vector here. अब देखो, यहां से जो फील्ड पास करेगी वो तो नॉर्मली होगी, लाइन चार्ज से अवे होगी, परपेंडिकुलर होगी. बट इस सरफेस एरिया का एरिया वेक्टर इज परपेंडिकुलर, normal to the surface. Now, what is the angle between E and S for the base area? It will be 90 degree. Okay. So for these two values, the flux will be 0. Why? Because flux is equals to E vector dot ds vector, and it is integration of E ds cos of theta, and here the theta is 90 degree for base area over the surface 1 and 2. So for surface 1 and 2, the electric flux will be 0. And you can also understand these electric field lines are parallel to the surface. So they are not crossing the surface. That is why also the electric flux through this surface, base surface, will be 0. Okay? Now, phi1 is equals to phi2, which is equals to 0, because E vector is perpendicular to area vector. Now, at the cylindrical part of the Gaussian surface, here also, does the field 0? No, field is not 0. Why? Because area vector is also in the same direction. Area vector is also same direction. So which means that area vector is is parallel to the electric field. And in that case, if you apply the Gauss law, E dot ds will come out to be as, I will show you here, E vector dot ds vector close integral q enclosed divided by epsilon naught. Now, E vector we have to calculate. E dot ds is E ds cos 0, because this is ds vector. ds vector and E vector are parallel. So due to parallel, the angle between them is 0 degree. So it will become E ds cos 0 q enclosed upon epsilon naught. So cos 0 will be 1. So it is come out to be as E ds q enclosed upon epsilon. Up, how much charge does this Gaussian surface will contain? How much charge does this Gaussian surface contain? Is this contain the total charge? No, because this is the infinitely long wire. तो complete charge तो नहीं है इसके पास. How much charge does it have? Since this is a linear charge distribution, so we can know that lambda is equals to line charge density. If I multiply this lambda with the Gaussian cylindrical length, which is L, which means this is the value of charge enclosed by the Gaussian surface. Okay? Lambda into L. I have told you many times that how to calculate this charge. So charge enclosed here will be lambda into L. And what is the area of this surface? Area of this surface, this curved surface, it will be 2 pi r circumference of the base circle multiply by the length. So length, the area will be 2 pi rl. E into 2 pi rl, because integration of ds will be integration of this entire surface. So it is E into 2 pi rl, which is equals to lambda L upon epsilon naught. If you solve, then you will get that E is nothing but lambda upon 2 pi epsilon naught into R. Okay? And the same expression we have did with the help of what? With the help of electric field concept in the previous lecture. Okay? If you put the value of lambda here, you can also put the value of lambda. If you know the value of this line charge length, capital L, so you can put the value of lambda, which is capital Q by capital L. Okay, but for now you can remember this expression, E is equals to lambda upon 2 pi epsilon naught into R. क्लियर है? क्लियर है सभी को? क्लियर है? इज दिस क्लियर टू यू ऑल? रेस्पॉन्स इन द चैट बॉक्स. ठीक है, सो दैट आई वुड नो. देखो, ये हमारे पास लाइन चार्ज था. ये हमारे पास लाइन चार्ज था. अब हमने पढ़ा है कि किसी भी लाइन चार्ज, किसी भी चार्ज से जो भी फील्ड है हम वो निकाल सकते हैं विद द हेल्प ऑफ व्हाट? विद द हेल्प ऑफ गॉसियन सरफेस. अब इस लाइन चार्ज से द फील्ड विल बी लाइक दिस. So what should be the Gaussian surface so that this field will either parallel or perpendicular to the area vector? So that surface would definitely be the cylindrical surface. This cylindrical surface. अब इस cylindrical surface के रेडियस कितनी है? स्मॉल आर है. लेंथ कितनी है? स्मॉल एल. अब देखो, सपोज दिस इज द इनफाइनाइटली लॉन्ग वायर. ठीक है, सो व्हाट इज द चार्ज ओवर दिस लेंथ एल? क्योंकि जितना लेंथ एल है इतना ही तो चार्ज इनक्लोज किया है ना. इतना ही तो चार्ज इनक्लोज किया है गॉसियन सरफेस ने. ठीक है, तो फ्लक्स विल बी क्यू इनक्लोज्ड अपॉन एप्सिलॉन नॉट. क्यू इनक्लोज कितना है? जितनी ये एल लेंथ है, एल लेंथ पे जितना चार्ज है. वो कैसे कैलकुलेट करेंगे? तो उसे कैलकुलेट ऐसे करेंगे, लैम्डा इज द चार्ज पर यूनिट लेंथ. चार्ज पर यूनिट लेंथ. सो चार्ज की वैल्यू क्या होगी? चार्ज इज नथिंग बट लैम्डा इनटू लेंथ. तो जिस भी लेंथ का आपको चार्ज निकालना है लीनियर चार्ज डिस्ट्रीब्यूशन में, यू जस्ट मल्टीप्लाई दैट लेंथ. हाउ मच लेंथ डू वी नीड टू नो? स्मॉल एल लेंथ का चार्ज वी नीड टू नो. सो चार्ज q इज इक्वल्स टू lambda into small l. So that is why this charge is coming out to be lambda l. Got it? And one thing you will also take, if this is a circle, it has a circumference of 2 pi r. Got it? And suppose I just extend this circle. I have placed another circle below it, another circle, another circle. I am made a full cylinder. Then what is the area of this surface? So this 2 pi r is expand to length L. So area will be 2 pi r into L. Okay? This is the area of curved surface, not this flat surface. फ्लैट सरफेस का एरिया तो, इस बेस का एरिया तो क्या होगा? पाई आर स्क्वायर ही होगा. ठीक है, दिस इज द एरिया ऑफ दिस कर्व्ड सरफेस. आई होप दिस इज क्लियर टू यू ऑल. अब इससे नेक्स्ट लेक्चर में वी विल डू फॉर इनफाइनाइटली यूनिफॉर्म चार्ज इनफाइनाइटली प्लेन शीट. ठीक है, ये हम नेक्स्ट लेक्चर में करेंगे और कुछ क्वेश्चन करके दिस चैप्टर वुड बी फिनिश इन द नेक्स्ट क्लास. ठीक है, so I hope you have enjoyed the session. If anyone has any kind of doubt, you can ask. Otherwise, you can leave now. The lecture is being over. Thank you so much for being attentive. Bye bye. Take care of yourself.